just recapping most of what happened in Unit 3. So hopefully you can use this to review for your test. There's a lot of information in this video. I'm not going to read every word. I'm not going to go over every little thing. I'm going to try to hit on the key points to make this video short. I am going to post the PowerPoint that I'm going over on Edmodo as well, so you can always reference back to that. So first thing for Unit 3, we're talking about production. Production is pretty simple, converting inputs into output, right? Taking resources and making something with it. Okay, a couple things you need to know. First, marginal product. That's the biggest one. Average product's easy to figure out. Marginal product, remember, is the change in total product over the change in inputs. Generally, it's going from one to the other, so you don't have to worry about, what's the change in inputs. It's always one, so it's just if you have one worker makes you 20, two workers makes you 40, okay, the marginal product is 20. All right, the law of diminishing marginal returns is the biggest thing in this unit. All right, we've talked about the law of diminishing marginal utility. The biggest difference here is you got to remember it's returns, not utility. A lot of times questions will put utility in there to trip you up. So returns is in terms of physical returns, physical product. Remember, utility means satisfaction. So in terms of the stages of returns, right, you have a couple different curves you could look at. So on top here, we have our total product. On the bottom, we have our marginal product and our average product. All right, so our total product, as you can see, goes up at kind of a fast rate and it starts to slow down. So if you look at the two of them together, when it's going up at a fast rate, that's where we have increasing marginal returns. How can we find that graphically? Well, on the total product, we don't necessarily know it, but if you're looking at the marginal product, it's where marginal product hits its highest point. Why does that happen? Well, it happens because of specialization. If you guys remember doing the widgets demonstration, that's when we had 3 workers, and one was stapling, one was cutting, one was folding, right? Everybody has a job. The next one would be decreasing marginal returns. Okay, total product is still going up because each worker is adding more, but they're just adding less and less. The next worker adds 3. The next worker only adds 1. All right, so there's just too much for them to do at this point. They have fixed resources. Again, back to the widget demonstration. We only had 1 stapler. We only had 1 scissor. Right? We only had 1 desk to work off of, so you couldn't really spread out. And the last one is when total product starts to fall. That's negative marginal returns. Remember, that's too many cooks in the kitchen, right? Workers are just getting in the way of one another. There's not enough jobs for them to do. Here, if you look at the chart, okay, with numbers, you can see it. If you look at the marginal product right over here, right, marginal product for the first worker, second worker, third worker goes up. Fourth worker, the marginal product is still positive, but it's less than it was for the third worker. Same for the fifth. It's still positive, but it's less than it was for the fourth worker. The biggest thing, and we've gone over this in class, questions like to ask you after which worker. Okay, for this one, if you get a question after which worker does diminishing marginal returns first occur, the answer is after the third. It's not the fourth. That is when diminishing marginal returns first occur, but it's after which worker. So any worker you hire after the third one causes diminishing marginal returns. All right, so real quick, we talked about accounting profits, economic profits, right? So accounting profit is what if you went up to someone in your family over this weekend and said, well, what do you know about profit? They're going to talk about accounting profit, right? It's revenue minus cost, okay? Economists, however, like to include implicit costs, which if you remember are opportunity costs, things that you forego. Okay, if you decide to work one job, you're giving up another job that you could have worked potentially. If you own a building, right, you decide to use that building for your own business, you're giving up the opportunity to rent out that business. Those are different opportunity costs that they might ask you about in different questions. Okay, and remember, everything we talk about, economic costs, unless it explicitly says accounting, which it will occasionally in a multiple choice question or a FRQ, like just one question that you have to write about. Okay, so the different costs in production, right? Well, first off, we have to look at the short run. Okay, remember the short run, it's not a specified period of time. The short run is not, okay, 3 months, 6 months, 9 months, right? The short run is when you can't change fixed resources. Here are all the different short run costs, right? We have fixed costs, we have variable costs, total costs, and then you just have averages of those. Average fixed costs, average variable costs, average total costs, and of course you have marginal costs. All right, what are the definitions? Again, I'm not going to read every one of them. All right, fixed costs, fixed resources, variable costs, variable resources. Total cost, again, everything added up, and marginal cost, change in total cost over change in quantity, right? How much more does it cost you to produce one more? Again, over the change in quantity, a lot of times it's one, so you don't have to worry too much about it. You're just looking at a chart and saying, okay, it costs us $20 to produce 2 units. It costs us $25 to produce 3 units. The marginal cost of the third unit is 5. Okay, let's look at a chart with all these different costs, right? So if you look at our total cost, it's simply variable plus fixed, okay? Again, notice the fixed does not change. Remember, it's a one-time cost. So we produce 0. Our fixed cost is 100. That could be something like maybe it's a lease we pay for a piece of machinery for a month. Maybe it's $100. Okay. If we produce 0, we still paid that 100. If we produce 7, we're still paying only $100. Variable costs again change because they're different resources, right? You know, raw materials, labor, stuff like that. Marginal cost, okay, again, it's just how much more. So from 0 to 1, it's 10. 1 to 2, it's 6, and so on. Okay. Average variable cost, simply take variable cost divided by the number. Okay, average fixed cost, take 100 divided by 1 through 7. And then average total cost, you can either add these two columns together, or you can take the total cost and divide it by the number. Okay, there's 2 different ways to figure that out. Again, remember, going back, the average fixed cost is an asymptote. It gets lower and lower and lower each time because the fixed cost does not go up. The more you produce, the lower the cost it is. It's an asymptote because when you look at it on a graph, which we will in a little bit, it just gets smaller and smaller and smaller. Like that. Okay, and then you have your average variable cost, your average total cost, and your marginal cost. Okay, so moving forward, again, that distance right there between the 2 curves, that is going to be your average fixed cost. The question that AP exams love to ask, right? What's the value between ATC and AVC, or they don't give you the average fixed cost and they ask you to find it. Well, you can find it by looking at the distance between these 2 curves at one quantity. So at 11, the distance between these 2 curves is right here. Okay, so let's look at a practice question, right? At output Q, what area represents total cost? So we go to Q. All right, let's go up to our average total cost. Follow up the curve. It's right there. All right, again, that's just our average total cost. We have to multiply it by the quantity. So the area is going to be 0, C, D, Q. All right, what about variable cost? Same thing. Follow the dashed line from Q, go all the way up to variable cost, and it's the same area. It's going to be 0, B, E, Q. Okay, and then for our fixed cost, same thing. Follow Q up to the fixed cost. It's right, going to be right there. Or you can look at it on top because, again, the distance between these 2 curves and the quantity is also the fixed cost. Okay, moving forward. So marginal cost, big thing in this unit, going to be a big thing for the next unit as well. It's a J shape, right? Okay, well, why is it J-shaped? Because as you hire more workers, you know, it costs you more, but they're giving you more each time. They're producing more and more. So let's look at the marginal product. Marginal product goes up, and then it goes down. Total cost goes up by a constant amount each time. And then if you look at our marginal cost, it goes down, then starts to go back up. So here, it starts at 2, goes down to 125, so it hits a minimum, and then starts going back up all the way to 10. If you notice, it starts going back up at the same time that marginal product starts going back down. That's something that I went over very heavily in class. You have to look at it and say, okay, if they only give me marginal cost, but they're asking me for diminishing marginal returns, I just have to flip it in my mind. Okay, if they're asking for diminishing marginal returns, which would happen after the second worker, it's when marginal cost starts to go back up. Okay, remember, they're mirror images of each other, and that is why that happens. Okay, and if you remember, the marginal cost, you saw this slide in class, the marginal cost intersects the ATC at the minimum ATC. If marginal cost is below the average, it's going to pull the average down. That's why. So any point that it's below the average, even right here where it's going up, it's still pulling the average down. Any time where it's above the marginal cost, it's pulling the average up. That's why it has to intersect it at the minimum ATC. Just mathematically, that's how it works. Okay, let's talk about shifting the curves. All right, what happens if our fixed costs go up to 200? Well, obviously our fixed cost column is going to increase. What else is going to increase? Our total cost, and then obviously the averages, right? If you notice, marginal cost does not change because even though the fixed cost changed and each cost went up, the difference between each is still the same. That's going to be very big because if you get a fixed cost change on a question, it's not going to change marginal cost, which will not change quantity. All you'll move is your average fixed cost, your average total cost. What it will change is it will change profit because as you see our average total cost went up. We're not making a different quantity, but our average total cost went up. Okay, what if our variable costs move? Well, if the variable costs move, obviously the variable cost chart's going to change. The total cost. Marginal cost changed, as you can see, because everything is now different. The differences between each are now greater. All right, average variable, average total. What's important about that? Our marginal cost moves. So we don't have a marginal revenue on here. Let's say at this one, the marginal revenue is right here. Okay, at that point, you would produce this quantity. It's on that line. Now we're producing this quantity. Okay, so our quantity changed. Now let's look at some long-run costs real quick. Again, the long run, it's when things can change. You can buy more resources. You can get more resources. Okay, to make it simple, only 3 things can happen when you increase your resources. You can get back what you put in, or you can double. You can more than double, right? Or you can less than double. Economies of scale would be quote-unquote more than doubling. That happens because you start to use mass production techniques, okay? If you remember the video that I showed you from Mr. Clifford, he's talking about the bread makers, right? The bread makers with all the machinery, right? They spend millions of dollars on machinery. Their total costs are incredibly high. However, they're making millions of loaves of bread each day. So their average total cost per loaf is incredibly low. And that happens because of mass production techniques, right? That's economies of scale. They increased their input by, let's say, 500%. Based on making it by hand, and their output went up 1,000%. If the output goes up more than the percentage of inputs you put in, then your economies of scale. Okay, so doing that, as we can see here, you have one average total cost curve, one marginal cost curve, then you have a second short run, you have another one. Okay, you experience economies of scale, you're still falling, mass production techniques are being used. Then you hit a point where you just cannot get your costs any lower. That's constant returns. You put in 100% more inputs, you get 100% more outputs. Okay, you can't get it any lower. Okay, you can't get it to 0 because you still have to pay workers. You still have to pay for resources. Then it starts to go back up because it starts to get too big, right? The firm gets too big to manage. You have to start putting more money into it. So you're putting in 100% more inputs just in terms of anything that deals with workers, but you're only getting 50% more out of it. Okay, and then if you just trace all that, you get your long run average total cost curve. Okay, and you have your 3 different sections right there. Okay, moving along, right to perfect competition, right? So perfect competition is many small firms, right? They have identical products. They're perfect substitutes for one another. It's easy for firms to enter and exit. There's no advertising, okay? Firms are price takers, right? They have no control over price, okay? They just take the price that's set by the market. Why? Because there's no incentive for them to raise the price. If they raise the price, no one's going to buy their product because their product is the same as any other product. Okay, a lot of this has to do with crops, fruits, vegetables, stuff like that. Generally, when we go to the store, we don't really care. I mean, not the canned stuff, but the fresh stuff. We don't really care who's selling it, what labels on it. If we go to the store, we're looking at fruit, we're picking up whatever one just looks the best because it's the freshest at that time. Because of that, they have a perfectly elastic demand curve. Okay, so back to Unit 2, strong regular supply and demand curve for the industry. Okay, that's what the industry experiences. You then draw your equilibrium quantity and price. You take that price, you go over, and there you go. You have your demand curve. Okay, if you remember, demand is also equal to marginal revenue. Why? Because if they're selling each unit for the same price, marginal revenue is constant. First unit's 15, second's 15. Everyone's going to be the same price. Average revenue is also on there. Rarely are you going to get asked about average revenue, but it's important to know that it's there. It's one of those things you just need to know, but you're not going to be asked that often about it. Okay, so you have your Mr. Darp curve. All right, so let's look at a graph for perfect competition right here. This is just up for the firm, obviously. So we have our Mr. Darp curve, draw our marginal cost on there, ATC, AVC, right? How much output should be produced? So MR equals MC rule still applies. So right there, okay? 9 units of output. What's our total revenue there? Well, it's going to be 9 times 7. Okay, that's 63. Our total cost, you take the quantity, follow the dashed line up to where it hits the ATC curve. You go over 5. Okay, on average, we're paying $5 per each unit. Well, 9 times 5 is 45. That right there, that's our profit. Okay, anything above the cost line, below the Mr. Dark curve, that'll be profit. Okay, well, what if the price drops to 5? Well, we're going to produce this quantity now because MR equals MC still holds. So 7. 7 times 5, okay, $35 in total revenue. Well, how do I find my total cost? I do the same thing. So now I got to go up a little higher. Take the dashed line, and I go up to where it hits the ATC curve. Right there. My total cost is 42. You notice my costs are higher than revenue, so therefore I'm making a loss. Right there, a loss of $7. What if it goes down even further? Let's say the cost goes down to 4. You now notice, okay, at our profit maximizing quantity, which is right here, which is 5, it's lower than our average variable cost. If you remember, that is the shutdown rule. This firm should shut down, minimize its losses, okay? Because if it produces 5 units, it has a total cost of 35 and a total revenue of 20. It's losing $15. But if they shut down, okay, they're only losing $10, which are their fixed costs, maybe, you know, paid for machinery, rent, stuff like that. So it's cheaper for them to shut down. So remember, marginal cost, marginal revenue rule, profit maximizing rule applies for all market structures only if price is above ABC. Okay, because if it's below ABC, they're just going to shut down. Don't make anything. You don't profit maximize making any quantity. Profit maximize by, or loss minimized by just shutting down. All right. Another way you could see the rule is price equals marginal cost. Because remember, you have Mr. Darp, right? Marginal revenue equals demand equals average revenue equals price. So if they say price equals marginal cost, it's the same thing. Okay, moving on to side-by-side graphs, shifting the graphs around. So we're looking at this graph. All right, we have the industry right here, supply, demand, price and quantity. Take the price over. All right, is this firm making a profit or a loss? Just by looking at it, you can see this firm is making a profit because at the profit maximizing quantity, ATC is below the Mr. Darp curve. Well, let's figure it out. Okay, for here, we're going to make 10 units. Okay, we're going to sell them for $20 each. So what's our total revenue? Total revenue is going to be $200. What's our total cost? I take that and I go up to my ATC curve, hit it right there. Total costs are going to be $150. So how much of a profit should I make? I'm going to make a profit of $50. Okay, is there anywhere on here that if it goes there, I should shut down? Well, I should shut down if it goes below the average variable cost, which is right there. Okay, so if the price gets below that, which is let's say $12.50, we should shut down. Okay, moving right along. If you remember, okay, you know, there's no supply curve on here. You might say, well, that's weird. There is a supply curve on there. It's just a different name. The marginal cost curve above the minimum ABC is your supply curve, as you can see right here. Notice I cropped off the J-shaped hook right there. Why? Because that's not technically part of your supply curve. It's above the minimum ABC. The ABC is up here. Then our supply curve would just be that part. Okay, how do we know? It behaves in the same way as a supply curve. Price goes up, quantity goes up. Okay, if variable cost increase, right? Let's say you get a tax, a per unit tax. What's going to happen? Average variable cost is going to go up. Marginal cost is going to go down. Okay, sorry, up. Marginal cost is going to go up, which is the supply going down, which is a shift to the left. What if you get a decrease in variable cost? You get a per unit subsidy. Well, the variable cost goes down, marginal cost goes down. It goes to the right, which if you remember is an increase in supply. So as you notice, it behaves the same exact way as a supply curve behaves. All right, moving right along. Okay, remember, in the long run, in a perfectly competitive market, firms will enter if it's profitable. Firms will leave if they're making a loss. In the end, all firms break even. They make no economic profit. Again, that does not mean that they're making zero money. They're making accounting profit. They're just making no economic profit, which means they can't go make more money doing something else. Okay, so this is what long run equilibrium looks like. Supply, demand, price, quantity. Take the price, go over. Draw your Mr. Darp curve. Draw your marginal cost curve. There you have our quantity. Throw out your ATC right on the quantity. Remember, the minimum ATC needs to intersect the marginal cost curve. Okay, firm is making a normal profit, no economic profit. All right, is this firm in the short run or the long run? Well, we know this firm is in the short run because it's not at long run equilibrium. It's making a profit. So if this market is profitable, right there, firms are going to enter. Firms are going to see that they can make money in this market, so they're going to enter the market as well. When they do that, supply goes up because there's now more sellers. When supply goes up, price goes down because there's more available. This firm is a price taker. So they have to take the price in the market. So their Mr. Dark curves goes down. They produce less because that's what maximizes their profit. 8 doesn't maximize their profit anymore. Now it's 5. They're now in long run equilibrium. As you can see, they're producing less, but in the industry, there is more because there's more sellers. What about now? Short run, long run. It's in the short run because they're making a loss. It's not at long run equilibrium. So if they're making a loss, what's going to happen? Sellers are going to leave because they want to go do something else where they can make money. They leave. The quantity goes down. Price goes up. The firm takes the price of the market. Okay, they're now charging $20. Their quantity goes up from 8 to 9. They're now at long run equilibrium. They're now no longer making a loss. So there you go. They're charging a higher price. There's a higher price in the market. The market, though, there is less quantity, even though this firm's quantity went up because a bunch of sellers left. So there's just less in general. This is going from short run to long run. Okay, you start in the short run. You end up in long run equilibrium. How do you know that? Okay, there's only one change. As you can see, there was only the change in supply. Demand didn't change. One change that increased the price or decreased the price. Now, what happens if you go from long run to long run? Okay, there's same things, just one extra step. Okay, we're in long run equilibrium right now. $15. Okay, this firm is making 8. Okay, same as before. Let's say demand increases for this product. It's a product that people really like. Okay, there's been news on it. People want to buy it. Okay, well, demand goes up. When demand goes up, industry quantity goes up because more people want it, but the price goes up as well. This firm is not going to stay at $15. They're going to take the new price set by the market. So they increase their price to $20. Well, what happens? Now they're making profit. Okay, this market is profitable. Doesn't stop there. If this market is profitable, remember what happens. Now firms are going to join. So our supply is going to end up going up. When supply goes up, we end up back at $15. If you remember, all of the questions you're going to get are going to tell you constant cost industry. If it says constant cost industry, you end up at the same price. They do that to make it easier for you. Okay, because if you have an increase in cost, it ends up somewhere in here and you have to try to figure it out. It's less work just to do constant cost industry to make life easy for you. So price went up to 20 because of the increase in demand. Supply increase, which brings it down. It goes back to 15. You need to make sure you go back to your original price. There you go. We're back at long run equilibrium. This graph is the same as where it was. This one is not. Supply increase, demand increase. The price is the same. Industry quantity changed. They will ask you about that. Okay. Industry quantity has gone up. Why? Because demand and supply both went up. Okay. Going back, let's say demand went down and as a result supply goes down. We're going to end up back here as well. This graph will end up in the same exact spot. What will happen here though, price will be the same, quantity goes down. Okay. So you just need to make sure you're paying attention to industry quantity. They'll ask, well, what's going to happen to the price? Price returns to the original. What's going to happen to the firm's quantity? Firm's quantity returns to the original. What happens to the industry quantity? Well, the industry quantity either goes up or it either goes down. Okay, last thing from this unit. All right, we have efficiency. So productive efficiency is where price equals minimum ATC, or just a way of saying producing a good in the lowest costly way. Okay, So this product is not being made at the lowest possible cost, because here, where they're maximizing their profit, it's right there. Lowest possible cost would be minimum ATC. This firm doesn't care about that because they're maximizing their profit. Yes, they're paying a little bit more for these units right here, but that doesn't matter. They're making more money. Same here. They're trying to minimize their loss by producing their MR equals MC quantity, but they're not producing at the lowest average total cost. Do they care? No, because if they produce enough to get it down there, they're going to lose even more. Their loss box would go all the way over to here. Now they're producing at the lowest minimum ATC, right? And that is the lowest possible cost. So here they are productive efficient. Okay, that happens only in the long run for perfectly competitive firms. Got it? Perfectly competitive firms, they're only productively efficient in the long run. Well, what about allocative efficiency? Well, that's where price equals marginal cost. If you remember, price also equals marginal revenue. So it simply means where marginal revenue equals marginal cost. Well, guess what? That's where we produce every time. It's the optimal amount being produced. MR equals MC. So firms, perfectly competitive firms, are always allocatively efficient because they always produce marginal revenue equals marginal cost. Okay. Well, what if they want to make less units? They're not allocatively efficient because they're not making what society wants, and they're not maximizing their profit. So they're not going to do that. They're going to go up and they're going to produce 15 units, even if they're making a loss, because that's not only their profit maximizing, it's their loss minimizing. What if they make 22 units? That's too much. They're not producing what society wants. They're producing more than society wants. Also, they're not maximizing their profit. They're still making profit at that point. They're not making as much as they are here, though. Okay, so remember, in the long run, they're productively efficient, allocatively efficient. In the short run, they're only allocatively efficient. Okay, so hopefully that helped you. Hopefully you get a chance to watch this video. For period 2 and 6, your guys' test is on Wednesday, which is the 28th. For period 5, your test is on Thursday, which is the 27th. I'm going to post this PowerPoint on Edmodo with it if you want to look through it. Okay, a lot of it's the same stuff as we went in class. I just grab slides from different places. Again, hopefully this helps you watch online videos as well. Okay, not just mine. Hopefully you enjoy the long weekend, enjoy the holiday, and I'll see you guys later.